Hey everybody, welcome to Houdini Hangout. My name is Peter, and glad to have you with us this evening. Um, Looking forward to kind of getting back into things. Um, it's been a couple of weeks for me. I was in SIGGRAPH. I was in Vancouver attending SIGGRAPH, and it was pretty fun. I got to do a little presentation from our education team while I was there, and it was a good time overall, and got to participate in a Houdini battle while I was there as well, which was uh, super stressful. A lot of fun though, and was certainly one of the highlights of the week with us being there. But got to have a lot of meetings with a lot of really cool people in the education world, and so it's really great. I had a wonderful time. Even got to go with my wife, which was pretty cool. So it was a really different experience for me at SIGGRAPH, which was really fun. So took a little bit of time to kind of get my brain back into things, but at this point, I'm feeling pretty good, ready to rock and roll. I'm seeing that my internet doesn't look so great, but let's just give it a shot. Hopefully, it'll be okay. I don't know what's going on. Apparently Tuesdays are no good in my neck of the woods for streaming. I really don't understand. Wednesdays have been fine. Tuesdays seem to be an issue. So thanks, Zach. Hopefully my stream is okay and is not absolutely horrendous to have to watch. With all the I don't know. I don't know what's up. Something's wrong with Tuesdays apparently in Buffalo. I don't know. Anyways, so I was thinking of doing some wire stuff tonight, doing a little bit of, having some wires connected and things like that, doing a little simulation. Sorry, everything is like flashing at me right now, so it's like super distracting. I really wish I could actually get it to stop at this point because I'm just gonna want to try to power through it. So sorry. I think I'm going to be turning that to just ignore it. Please let me know if in the chat if there's any type of major issues with my internet or anything like that. And I think there's going to be major issues tonight is my guess, but we'll see. Anyways, just a little disclaimer to start off with here. I usually like to just kind of say that obviously I am not the for the world's expert on Houdini. So if you guys have any thoughts or questions or comments, please drop them in the chat. I'd love to hear them. And that's pretty much it. Just love to have a conversation as we go here. And the more the merrier. So hopefully you've got some comments or anything like that you'd like to add. So so let's get started. So I think what I'm thinking that we're gonna do is have kind of like two different like attachment points for geometry and have like wires kind of stuck between them. I'm not sure if we should do it like horizontally or vertically. I was thinking vertically originally, but now I'm thinking horizontally might be a little bit more interesting because we'll get some of that gravity kind of affecting the middle. We could maybe drop some stuff on it as we start to build the setup. And I think that might actually be a little bit more interesting. I don't know. I could go either way with it, but so let's get started. I'm going to throw down a geometry node, and I'm going to just call this geo. We'll call this line setup. And give it the old green color so I know this is like some of my geometry stuff. And let's just do a grid here. We can, let's do it. Let's do it horizontally. Why not? So we'll do it on the XY plane. Great. So let's say that this is going to be like this. And actually, I'll just move it mathematically. Let's do it -5. Oh, wrong axis. So let's do it this way. and we'll just do it -5 back like this. And we'll do maybe, we'll do something a little different. Let's just do a circle. And we'll put that over here. And why don't we put this in the same plane, and we'll put this, I don't know, 5 in that direction. And maybe I'll just scale this up a little bit. This will just maybe make it a little bit more interesting where it's not going exactly to the same shape. It's kind of, moving across in some sort of maybe more interesting fashion. So there we go. We've got that. We've got our circle and our grid. Looking good. Let me just put down groups here. Now with Vellum, a lot of times you kind of have different, your different geometry streams that are coming into your Vellum setup, and being able to have groups on them can be really helpful because you can actually, you can kind of tell it to, you can basically tell it to look at the collision geometry and the, like, your Vellum, that you're building all your constraints on. You can look at that geometry, and you can use groups on them to kind of target different sections and things like that. So that's what I'm going to do. I'm just going to call this, let's see here. We'll just call this left grid. And I'm just going to make another group over here and call this right circle. Can't have spaces in groups, so just something to keep in mind. Let's see here. Yeah, that should be good distance-wise. Hey, Tom, how's it going? Glad to have you with us tonight. I kind of just realized that Tom works with Deb Isaac, and she was one of our great education people that we met with when we were at SIGGRAPH. So, and she also did the Houdini battle. So it was really cool to get to meet her. And yeah, it was pretty fun. Oh yeah, there we go. Probably should save. Thanks. Thanks Houdini for reminding me. I was playing around with these a little bit before, just so I can make sure that things are good. I know Deb is great. She's like a powerhouse. I don't understand. She's got like more energy than I think I've ever had in my whole life. So she's got some great ideas. Deb runs Houdini School. So if you guys are ever looking for some cool training, I know that they have awesome stuff at Houdini School. So that was pretty cool. I also got to meet Fraser, who is with Hip Flask, I believe it is. And he was awesome as well. He's out of Australia. And so, yeah, huge props to everybody there. They were great, a lot of fun to meet. So I got to meet some really cool people at SIGGRAPH. Okay, cool. So we've got these two things here, group, great. I'm just going to do a null here. I think this will be the easiest way to do this. I'm just going to say in left geo, and then this will be my in right geo. So we'll just have those. I can always grab from those, and that'll give me my kind of source geometry here. And it'll let me, basically just, point to those later down in the network if I need to or whatever. So, okay, we've got those. Let's just scatter some, oops, I think I hit the wrong one. Scatter some points here. And clearly not going to want to do that many. So let's pull that down. In fact, you know what I'm going to do? I'm just going to do something for fun. I'm just going to do a little control group here, or a control like null. I'm just going to call this control. Actually found, oh, cool. Thank you, Random Render. Looks like I got a tip there. Pretty cool. Thanks, man. That is officially my first time that's ever happened. So thank you so much. So with this control here, what we can do is we're just going to open the parameter interface. I actually saw somebody do this the other day where you can just click on these and make them invisible, which is really nice. And then I'm going to put an integer in here. I'm going to call this number of, I'll just call this number, maybe we'll just call it wire number, something like that for the name. And then we'll say number of wires. Hopefully this will just be helpful to have. Yeah, hi, hi, random render. Thanks. Yeah. So, anyways, got this control here, and what I'm going to do is copy this parameter, and I'm just going to put this into the force total count here, and then that way we can use that to drive how many wires we're making here. So the other thing I'm going to do is I'm going to go into the number of wires and set this to 1, lock that down so it doesn't go below that, and we can, I don't know, just do like 100 here if we need it. Probably won't, but so now we've got our scattering number here, so that's all good. And I'm just going to copy this over and make another scatter over here as well. So now both of these are going to be getting that same number of points. And I'm going to now merge those together, and we start to have some, we got both sides here. And what I'm going to do is I'm going to put an ID on each side so that we can kind of connect them together based on the IDs. So you can actually use the enumerate to do this, kind of a built-in way of doing this. There is also some extra stuff that I'll use, like AEID is pretty nice. If you've got AElib, it's kind of the same exact thing, just point enumerate. But this is like a built-in one. So we can just do ID, or we could do index too, because then it's not going to really fight with any of the Vellum stuff later. And I'm going to put this on the points. So now we have our index number there. We can do this over here as well. So now all of these have index numbers, and we can match them together based on their index. So for that, you can actually just use the add sop, and we'll put this down here, and I'll do it by group. And what we can do here is by attribute, and I can do index. And now those will all connect based on their index. And I don't remember if this has a, no, it doesn't. So if we wanted to change that, kind of the easiest way of doing that would be adjusting the scatter, like your global seed here. If you adjusted both of the global seeds, it will randomize, but it probably just makes sense to just adjust one. You really don't need to adjust both of them because they should more or less adjust randomly. I mean, I guess you could do both. It depends. Another thing that can help as well is just adding in just like a random seed on that if you wanted to. But I'll just add a seed in here as well, just for fun, just to kind of make this a little bit more, let's, maybe make it a little bit more like we're making a tool here. So we'll just do a random seed in there, apply that. It doesn't really matter what this is. We'll do 2048 just to be mathy. Cool. So there's our random seed, and we can then drive both of these from that. So let's copy that parameter, and we'll just paste that relative reference. Paste that relative reference there, and we can just offset this as well. So we'll just do like just a random number in there to offset it by. And so now if we change this random seed, we're going to get these all to kind of shift around and change. So obviously you can quickly shuffle all your wires that way. So you could do it with one, you could do it with both, however you want to do it. It's totally up to you. But okay, so we got add there. We've got our ends, but we don't have any intermediate points. Obviously with Vellum, you're going to want to have like multiple points there so it can bend and move and things like that. So let's do a resample. That's the quickest way of doing this. And this is going to be quite a bit too many. So let's just change this and kind of see if we can visually get it to a good spot. I think that'll probably be okay to start with. We might even be able to go to like 0.25 or something. Yeah, that's probably good. Something like that. I don't think so. Some of the issues with getting too much geometry in Vellum is that you can actually, it can have a hard time like kind of satisfying all the constraints and things like that. If you have too many points, it can just kind of get weird. It can get too stretchy and do all sorts of weird stuff. So just keep that in mind. You don't want to really go too crazy with Vellum. I mean, unless you need a ton of detail, and then you're going to have to add, some more sub steps or things like that in there to kind of satisfy those, those constraints. But anyways, yeah, so we've got all of these points here. So let's now, I am going to use the curve U, quick curve UV, sorry, from AElib. I really like this because it has a couple of built-in things that are really nice. I'm going to turn off the visualize here. Turn off those points. So the one thing that I'm going to use here is use the start and end attributes. Basically what this is going to do is make a start attribute at 0, at kind of the curve U 0. And then as we go up to 1, there's going to be an end there as well. It's just a real quick way of doing that. And then we can do the group expression. And this is just a quick way of just kind of making a couple different groups. So I'll say this as start, and then we'll just do at start greater than 0. And that should give us, and we need to do these as points. So that'll give us the start points. And then, we don't need to duplicate that because this can do multiple. So we'll just do end as well. And we will do at end greater than 0. And so now we've got those two groups made. And we're kind of getting close to being ready to start playing around with some Vellum here. So yeah, obviously we've got all these intermediate points. We've got our two groups set up. Yeah, I think that should be enough for right now to kind of get going with this. So let's do the wire. Vellum. We'll just do a Vellum constraints. There's a hair preset, but I've noticed that I like using the string one a little bit better for this type of thing. I feel like the hair doesn't have orientation, if I'm remembering correctly. There's some weirdness there. I think it doesn't have one constraint that it builds by default. So anyways, so this is going to make all of our these kind of string constraints, and I'm going to just call this, let's see, we'll just say wires. The reason I'm doing that is that it's going to name it based on this tag here. And if we look at our constraint geometry on the primitives, we'll see that we have this constraint tag that's set to wires. So now all of these are set that way, and they all have that tag set on them. So that's really all we need to do right now. We could probably just reduce the stiffness a little bit. So we're set to, I think that's, what is that? 1 billion, maybe 10 billion, not sure. Million, 10 million, 100 million. Yeah, I think it's 10 billion. So we'll maybe just bring it down a little bit. I mean, I'm not sure how much that's going to even really make a huge difference right now, but I don't want them to be like stiff. So cool. That's great. Let's see. Let's add a thickness onto this also. So why don't we just do calculate uniform? We'll visualize the thickness there. And I feel like I want to make these a little bit bigger. We might, if we have some time, I might have some geometry kind of attached to these and figure that out. So kind of want to give it some thickness so that if we attach geometry, it can actually, have a collision basically. Like these are going to be our collision spheres here basically. So let's do maybe 0.75. Yeah, that's good enough for now. We can always make that thicker if we want to after the fact. So we've got those set. What we want to do is set constraints for each side. Now you could just pin those, but what I'm going to do is actually have this geometry up here. I want it to be like moving and stuff. So instead of having there being like animating geometry at the beginning and all that kind of stuff, basically what I'm doing is just pin it to that geometry and then rotate it. And then that will, those constraints will rotate with it. So what we can do is we can do another constraint right there. So let's call this, I don't know, left pin, something like that. And what we can do is we can actually bring both of these into here. They're going to be collision geometries anyways, just to make sure that things don't, you know, fly through it or whatever. So we're just going to put that into the collision input here. And so now if we look down here, we have this distance. We don't want a distance along edges. We want it to be attached to geometry. So you can see here now we've made some pins, right? We've got some pins going on there. And let's do this. We can take the geometry group. We can start with points. That should give us our start and our end, because the geometry is this main kind of portion of our Vellum you know, geometry that we've got here, which are these wires. So we want to take the points from that, because that's where we set the point. That's where we set the groups. So let's just do, I want to say start we'll do. How's that working here? Interesting. It's still doing this side. That's odd. Well, let's get the primitives here. Target group. Let's see here. So this should, oh, right. That's why. Those are points. I've grabbed the wrong part. Okay, so what I actually want to do is not take this part. That was my mistake. So we'll move this over. I'll cut that wire. What we actually want to do is, I'm just gonna do an object merge here, just to maybe make it a little cleaner. I'm not sure how much of a performance hit this is, but whatever. It's such a minor thing right now anyways. So let's just grab those places a little higher. This will just make it hopefully a little cleaner here. Left geo, right geo. Great. So that's just making it so I don't have these crazy networks being set up here. Anyways, let's just clean this up. Hit L. Cool. All right, so we'll just say get input geo, so I know that's coming from somewhere here. Okay, so now we should be able to pin. There we go. That's what I was hoping for. So now we're just using these start points, and let's target the group of left grid just to make sure that we're only getting these attached here. Now, one thing to keep in mind here is that you can turn this off, this closest location on primitive, and it's going to make that attachment to the closest point instead of the closest location on the primitive. So that is kind of an important toggle there, just to make sure, like, you know, if you want it to be, if you want it to be the closest point on there, that's fine. You can turn that off and make sure it's attached to a specific point. This is attaching it to just anywhere on the primitive, just the closest location. So, yep, same thing. This is kind of, this'll, what's that doing? That's just doing it to the closest point. That's interesting. I don't know why. Huh. I'm not sure what that specifically is doing, but anyways, I don't know why that was making all weird ones. Might be because it's like doing it numerically, like making the constraints like not by position, but by like index number, like 0 through whatever numbers we've got here. 50, I think right now, right? That's 67. Actually going to turn that down. We don't need so many right now. Let's just do 20 to start with. That'll be good. All right. So we got our left pin. Go away. And let's do another. I'm just going to just alt drag this because it's basically the same. And we will do, instead of left grid, we'll do right circle. Now you can do it like that and see it. Now it's actually trying to connect it from these points, but I can just take the, end there. Great. What happened there was it's trying to do it from all points. So all points were trying to connect to that, which clearly isn't what we want to do. So let's do end. That'll create that connection there. And what I'm going to do over here is transform. And I think what I'm going to do is grab the circle here. And I am just going to rotate it around the x-axis. It's kind of hard to tell. Is it this one? Oh, probably should be on that. Cool. Let's see. Yep, that's what we want. Okay, so I'm just going to set that up before we get into the simulation. Maybe at like 24, we'll start rotating it. And I don't know, 120, we'll get a half rotation. So we'll do 180 there. We'll just leave that as is. So then it's going to go and kind of twist. Should be kind of a little more interesting to see. from that standpoint. I don't think we'll see any of that changing. Nope. So we have that. Let's just throw down Vellum solver, if I can type. There we go. Solver. I'm just going to give it a couple extra substeps for right now. I don't know, 3 maybe, just to give it a little bit of extra. Let's just see where we get with this. Should have some gravity there. Yep, cool. And those constraints are moving. All looking good. Yep, we've got a little bit of jittering going on here. Yep. As I would expect, we want to probably push those substeps a little higher. So let's do that. Let's give it, I don't know, 6 to try out. See if that's any better. Oh, you know what? It's probably the stiffness is probably actually what the problem is here, because we still have that up quite high. So let's grab that, because that's really what you're trying to do, right? You're trying to solve the constraints that you've given it, right? So like you're trying to keep the stiffness in those, but as you're twisting it, you're adding all this like tension to it. So let's adjust that. I don't know, 10,000. Let's try that. Let's see where that gets us. It's going to be a bit saggier, which is fine. Yeah, this is feeling better already. Cool. Okay, you can see that it's respecting those thicknesses that we've set in there. We're getting a pretty stable result. This has 6 substeps, which feels pretty good. I think with some let me turn on my my real-time toggle here. We are getting still a little stiff and weird in there in some of these things. So, still a little jittery. Might still be a little too stiff. So let's just pull this down by a factor of 10 again. See if that's any better. I wonder if I could turn the thickness off on the end. See how I'm getting these like, it's like colliding with the surface there. I wonder if I could turn off the end thickness, if that's part of the issue. Might be. Yeah, let me actually try that. I had never tried that before. Let me see. Where do I do that? Sorry. Kind of thinking about this on the fly. Which is what I normally do anyway. So, all right. So we've got our rest lengths here, stiffness. Actually, I think that's on the actual points themselves. P-scale. Okay. Oh, you know what? They don't have any mass? That's weird. Kind of want them to have some mass. So let's see. We'll calculate some uniform mass on those. See if that helps. That actually might help. Because right now I think they have no mass. So I wonder if that's where some of that jitter's coming in. They just don't weigh anything. I love these shapes that it kind of makes in here. It's pretty fun. Nah, it still seems like we've got, it seems about the same. There's really nothing else happening there. All right, I'm going to tweak these because I really think that might be part of it. All right, so, is there any way I could do that in here? All right, so I am going to just do this. I will just do an attribute adjust float, which should actually be set to p scale by default. Yeah, not that one. We're going to grab this guy. And what I can do is just is there no thickness by attribute? I think the thickness comes from the p scale, if I'm not mistaken. I think that's the thickness attribute. And I'm going to test that right now. So maybe not, maybe maybe it is something else that I'm missing, but I'm pretty sure actually here out there's the thickness. So if I change this here and set this to yeah. Yes, that's right. You can do that. Thank you. We could do calculate varying. Yes, you're totally right. I could do that. So what I could do here is do like something like thick scale. Yep. This is a much better way of doing it. Thank you. By attribute. And we'll just say thick scale. Yep, that takes them all away. But now if I do this and set this to the groups, which here are start and end, I should be able to do that, I guess. Start, end. But why did that not do that? That's weird. Why is that not doing that? Attribute name class. Huh. I don't understand that. Well, I guess I could just do an attribute create. Guess that's more or less the same thing. I don't really know why that would be the case. That's weird. I don't know what the deal was with that. Let's see. Thick scale, like that. The default will be 1. These values will be 0. Here we go. Cool. Should be great. Let's see here. Let's see what happens with that. Thanks, Tom. That was a great comment. Thank you so much, sir. Yeah, that looks better. Looks like we got a nicer connection there. Now those things aren't like trying to stay away from the geometry. They're actually just attaching to it because it's not even trying to calculate the thickness of the wire at that absolute last point. Yeah. So, all right. So I've got this going on, and I was thinking it would be kind of neat to do, to like have them like pop off of like one of the sides. Maybe, I don't know. I'm not sure which side would be more interesting to have them pop off of. Yeah, we're still getting some jittering there. I don't love that. Yeah, you definitely could reset the thickness of those. I could even do something like what I could do. Yeah, I know that all of the P scales are the same basically. Like these are all going to be identical more or less across them. What I could do is do like I could promote it by primitive, basically, up to a primitive attribute, and then drop it back down to a point attribute, just to set it back, basically. These are varying, so I wonder if I could do. No, I can't do that one. Interesting. Yeah, so these are all different too. Okay, because I just want to see here. Calculate uniform. Yeah, see, I like that better when they're all exactly the same. You know, I don't know. I'm actually thinking now I like that because what's going on here is there's slight differences in the length of these, I believe. So when I do calculate varying, you're getting these little differences here, and I don't really love that, especially if that's going to be used at the end of it. I would prefer those all to be the same. So I think what I'm going to do, that is interesting. I think I'm going to do calculate uniform. I'm going to leave that. And then I am going to actually, I'll just disable that. It's not really going to make a big difference. I think I'm still going to do it down here, but I'm just going to do a point wrangle. I don't know why the attribute adjust wasn't working, but I'm just going to do this. I think this should work just fine. I'm going to change the p scale. I'm going to say at p scale equals 0. And I'm just going to run it over those groups. And now we have uniform. Yeah, I like that better. Because you brought up a good point, Zach, is that like what I was just thinking was like, oh, I could promote it up to a primitive attribute, average it, maximum, whatever. But then it's going to be very small difference, but the collisions might not match up. So you could run into that issue. It's probably not going to be an issue in this case, but I don't know. I'd rather do it a little cleaner. That's frustrating that you don't have it. Like, why this calculate uniform? Like, it calculates a uniform thing here, but then it doesn't give you the option to scale this here. It's like there, but it's grayed out. So I'm not totally sure why that even exists. That's kind of strange. Because like I could set uniform as well, or calculate uniform. I don't know. Yeah, it's a weird difference, but I'm just trying to think about like the most stable way of doing it. I feel like if you have every point position or every p scale the same, I think that'll be better. I might be wrong. It might not make any difference at all. So I'm just kind of thinking through this stuff as best I can. So hopefully that will do it. The other thing that we could do as well. Yeah, I agree, Tom. It doesn't seem totally intuitive. I'm not sure why why both calculates don't have that attribute drop down, and the varying makes sense, but I feel like there should be an intermediate step there where you can scale it by an attribute but still have it uniform across. Like, it's just weird. It's a weird thing, but this works too. And that's the really nice thing about having things like Vellum in SOPs, right? You can just throw a point wrangle down and just be like, well, fine, I'll just make an attribute wave wherever I feel like it. It's going to listen to it too. All right, let me try a couple things here. We still have kind of small enough geometry that let's see if substeps will do it. This shouldn't slow us down by too much. It's going to slow it down a little, but we're still getting 5 frames a second. So, I'm not going to lose any sleep over it. Just kind of want to see if we can get a more stable solution. If not, that's fine. We can at least understand some of what's going on here. I think that's the toughest thing with simulation, is getting that stable state, right? That's always the toughest thing in any of these simulations, is getting that might be, no, it looks like it's still jittering. I'm really surprised by how much that's going. I'm gonna turn this down. We don't need to go so far, probably. Prior to that, everything looks great. It's just at this last stage here, everything gets a little jittery. All right, I wonder if so this was one that I was looking at before. I'm just curious if this is going to make any difference. So this post collision passes kind of has to do with how they reference how many layers are stacked together. So let's see if we turn this up, if that does anything better for us. In fact, I'm gonna actually do a couple things here. Let's change this for a second. We'll just do it to like 168. Apply that, and I'm gonna do a little flip book of that. I almost called it a play blast. Yeah, so I think so. Yeah, I think you would want to try to do substeps first. In fact, like with things like fluid, I'm pretty sure that there is, even in the documentation, you'll see them mention with fluid, you want to start with like 6 substeps or something like that. Like if you're doing vellum fluids. So yes, I would definitely trying substeps, try constraint iterations. That's the next thing I'm going to try. I don't always see a huge difference with like a ton more constraint iterations, but yeah, the damping unfortunately just really kills the velocity. Now we could add a little bit of damping here and probably be okay because this is a pretty small change that we're seeing. Yeah, we could probably add a little bit of damping in there and that'd be fine. But yeah, I like to try to get it a little more stable just from like substeps and things like that. So this didn't seem to do anything. So let's just try this. Give it a oh, I moved. Dummy. I've always moved my my like viewport camera and I just forget. And I just like, oh, shoot. I wanted to like A/B it, but whatever. It's fine. We'll be able to tell if it's jittering or not. Like it's not the end of the world. I should have made a camera first. So while this is going, it was pretty interesting. Like doing the Houdini battle at SIGGRAPH was very interesting to have someone commenting on my work as I went. It's the first time I've ever really had anything like that in Houdini, and it was wild. It's a very weird feeling, but it was fun. It was cool though. Those guys were pretty funny. So. Yeah, let me see if I can find that. Actually, ooh, that looks. It's hard to say. Maybe that's more stable. Let's see. Playback, please. It might be moderately more stable. Yeah, let me actually do a Vellum configure fluid. I'm pretty sure if you go into the help documentation for this. Right. Yeah. In this case, it was just, you had to hear, and everybody was oohing and eyeing and stuff like that. It was funny. So not at my stuff, but at other people's stuff. All right. So yeah, here it is. Grains of fluid often require more substeps. Recommended that any attached Vellum solver be raised to at least 5 substeps for stability. So yeah, I could see anywhere up to probably 10, honestly, if you're doing like fluid stuff. So yeah, I remember reading that recently. I mean, obviously the fluid is a pretty recent update to this. So, but yeah, that's obviously quite high. So yeah, let's try a little bit of damping in there. Oh, you know what? The other thing, it could actually be these stiffnesses. Actually, now that I'm thinking of it, let's just try turning these down a little, because technically there is a small constraint here, right? So it could be those. Let me try that first before I do any crazy damping or anything like that. Let's just turn these back down just for fun, just to see where we get. Because technically those little tiny constraints could be, in fact, you know, I'm going to turn them even down lower just to make sure that we can rule them out for sure. Maybe. All right. Let's just do this. We'll do some damping in here. Probably in here. Maybe we'll try this first. Give it a shot. Let's see. Maybe it might be the bend. Damping might be more helpful here. Not sure. We'll see. We'll see what's what. Yeah. Yeah, you could use plasticity. Yeah. If you're not familiar with plasticity, that'll deform, and um, it will. It's basically like if you dented metal, that's like plasticity, right? Like you could potentially like have it just actually deform and then stay that way as like its rest state. It's like just deforming the rest state basically. So, but yeah, that is an option. Honestly, I feel like this is pretty stable. I mean, it's not perfect, but it's close enough, I think. So maybe we'll just call that good. The only other thing I was thinking, maybe we just try some bend damping. I don't know. We'll see. Let's see that last one, and this might be, maybe it's too much. Gosh, I have a fly flying around in front of me, driving me nuts. So if you see my eyes going like this, it's a fly. I don't think this is going to help it, but we'll see. Well, my internet seems to have calmed down. I haven't been having red things flashing at me, which I appreciate from just a sanity standpoint. Yeah, that's close enough. We'll call that good. It's pretty much fine. It might get worse. It might get better depending on if you had more wires in here, it probably would get worse, but who knows? The other thing too is if you have more wires, you might need to add more stretch just so that they can actually like be loose enough to twist on top of themselves. So what I was thinking is having them detach, right? So it's pretty easy to do this in bulk. So what I was thinking is like having them like stretch up like this and then let go on some level, right? And maybe what we would do is, oh, you know what we could do? We could do something kind of interesting here. So maybe as this twists, maybe when we get to here, I'm going to add in a translation step and have this like move up. Yeah, that's what I'm going to do. I'm going to do something hopefully kind of interesting here. There we go. I'm just going to turn this off so it's not simming anymore. And I'm going to add back in some of those frames. Just go all the way to 240. I can always turn it back down again. And let's have it, I don't know, 168 here. Oh, right. Oh, do I have that in here? I sure do. Thank God. Okay. Oh, right. Sorry. I was just going to change the thing, but yeah, I can just delete this and move this over. It doesn't really matter because I know it's at 5. Great. Okay. Sorry. So we've got those there. That's weird. Why are those? Oh, it undid all of it. Stupid. Okay, there we go. Right, because it set the preset. Okay, so I'm just going to move the pivot transform 5 over like that just to make sure it's in a good spot so that when I move it, here we can move it. That's weird. Why is that 180? That's really strange. It's like offset. That's really weird. Why is it doing that? Is it like a 40? It's like at like a 5 degree. That's bizarre. I don't know what's going on there. Anyways, maybe something I just clicked there. But all right, we'll move this up and we'll rotate it around like so. Yeah, I don't know why it's rotated in this axis here. It's so weird. And I don't want it to go in that axis at all, so we'll just do it like that. All right, cool. Ah, yes, I can't have that this should be set to 0. That's weird. Oh, right. I didn't have a keyframe set there. All right. That looks good. So let's try that just before I have anything disconnecting, make sure nothing too crazy happens. So what I'm thinking here is that if these snap off, like they would just fall down. Oh, I have it disabled. If I have them just fall down like it is right now, it's not going to be super interesting. So I'm thinking if it's moving up, then at least they can like hang down or do something like that, right? So hopefully that'll be moderately more interesting. Kind of twist around like that, and then they'll move up like thus. And then we'll have the wires doing some stuff there. Cool. That seems to be good. Kind of an interesting little thing going on there. Okay, so what I was saying before about having them break, pretty easy to do. All I have to do is a constraint properties in here. We can just wire that into here. And what I'm going to have disconnect is this side here. Now, I actually don't think I set up any groups. I didn't. So I'm going to go back and set up those groups. So I'm going to call this, output group left attach. And I'm going to call this one right attach. And then in here, I should be able to grab those groups. Yep. So we'll do left attach, and I'll just do the activation at like, I don't know, 144. So I'll just do this at $F. It's greater than 144. Since that's a Boolean, it's going to analyze that every frame. And once the frame is greater than the $F, which is frame, it's a variable for frame. Once that's over 144, it'll set this activation to 1, and this will happen. So what we're going to do then is we can just set this to be remove as 1. So up until 144, it will be fine. And then from there, we can have it break off. So let's see what that looks like. So we'll let this go through. Moving, and then it should let go here. Boom. There we go. Now those are all going to swing out. Oh, interesting. That one got like stuck. Huh. That's really weird. It's almost like it's on the other side. Huh. That's really odd. Oh, you know what? I bet you it's because it's up at the top. And I bet you it's actually... No, it's not the one at the top. I thought maybe it was one that was at the top. Oh, it was. It was. Yep, that's the problem. It must have gotten stuck on the other side. Huh, interesting. One thing that we could do to fix that a little bit would be to turn our scatter relax iterations down a bit so it doesn't go all the way to the edge. Or we could turn the radius down a little bit. There we go. A little less pushing towards the edges. Let's do that for this one as well. Yep. I think it was just having a hard time figuring out what side that was on when it was up starting at this very top. I think now it should know. We might have the same problem there, but let's see. Let's see. turn those off in a second. Hey, look at that. Sometimes it's nice when you actually figure out something like that, you know? So here's where that damping is definitely going to come in to kind of bite us in the butt a little bit. And I think we're going to see that this has like this like watery kind of effect there. And I'm not loving that. Nailed it. First try. Yeah, I'm actually going to turn this back down or back up. I don't really think we got a ton out of it. And I would really, I can leave the bend damp. Well, let's just go back. Control middle click brings back the defaults. And I'm also going to check that. Cool. All right. So it is nice to get something when you like think that it's might be that, you know, it's just nice. Okay, so that's all well and good and interesting. But what I was kind of thinking might be more interesting would be to have those. Yeah, the debug itch. I love debugging things, honestly. I love like tech stuff like that. So it's kind of like in my DNA. So I guess that's why I like Houdini, because there's a lot of that like tech debugging type stuff. So what I was thinking is going to make it a lot more interesting is if you released them individually, right? If you had them not all disconnect at the same time. And I was thinking about how the easiest ways to do that might be. And I'm kind of thinking that adding an attribute to those pieces of Vellum geometry might be the easiest way to do it. So let's just first of all, let's just look at, I'm just going to add a null in here. Let's look at the constraints that are coming off of here first. So this is our constraint geometry here. Actually, let me turn these off. We don't need those right now. Okay, so there's our constraint geometry, right? We've got points. We don't have obviously any of these. Oh, wait. Oh, wait, we do for the wires. But so we've got points on the end here. We've got constraints there. We have, let's see here. So we've got our wire constraint tag. Actually, I didn't rename this. I'm going to call this right pin. So we've got our wires here. You can see the constraint tag. And then if we go all the way down here, there should be, yep, left pin and right pin. And there those are as well. So what I'm thinking is that if we use our left pin geometry, which is right here, we should be able to, or we could use, yeah, as long as we use that, we could have it look at this group here. We have groups, obviously, for each of these, right? We could do a few different things, but I'm thinking if we add a frame attribute and have it checked together in the solver, then it should let go. Those should get removed when, when it's looking to, when it's going through that. So anyways, sorry, my brain shut off for a second there. But anyways, I think, so here's the thing that I'm not 100% sure on, and I was trying to check this earlier, but I never really got to it. So let's see if we can figure it out. So I'm pretty sure what this is going to do, if I'm remembering correctly, I'm just going to let this go down to here maybe, because it's going to let go at 144. So I just want to see what it's going to do here. Okay, so that's collision geometry, wrong one, constraint geometry. So let me just see what happens at 144 here. Let's see, can we do this? There we go. So the left pins should get removed here, but what is happening on this? I feel like it's setting an, attribute there for one frame. I'm pretty sure it's setting remove equals 1. Because here it's gone. A pseudo property. That's the first time I've ever seen that. A pseudo property that'll cause the constraint to be removed immediately when set to 1. Okay. Well, let's give it a shot. What's the worst that could happen here? All right, so I'm going to turn this off. Let's do a geometry. Oh, you know what? I was playing with this before, and you know what I bet you it was? I bet you it was that I was doing it on the wrong one. I was. That's the problem. So we're going to do this on the constraint geometry. So this is DOPS world, right? So this isn't SOPs anymore, so things get a little wacky, right? So this is a geometry wrangle. It's not technically the same as an attribute wrangle. I pseudo understand that. I'm not 100% sure what that means as pseudo property. I kind of want to ask somebody that now. That might be a question I pose out there to some of the developers to ask what a pseudo property is. But so there aren't point primitive. There isn't like an attribute wrangle in here. There's a geometry wrangle because you have to be working on a specific, specific piece of data in here, right? So in DOPS, since we're inside of here and everything now says dynamics here, so this is technically DOPS, even though we only dove in one little network here. This is DOPS world now, so things get wacky. So instead of working on our straight geometry setup here, we can't work on the geometry itself because geometry is the Vellum geometry. If we go to constraint geometry, that is where we have all of these things, right? So we have to turn our geometry wrangle over to constraint geometry. Make sure I'm typing that. Make sure I spell that right. Okay, cool. So that should now work because I was doing this before and I was like, why is this not working? That's weird. And this is probably the reason. So now we have constraint geometry. Let's see if we can't do this. All right, so we have our left pins here, right? So let's do this. We'll only... Oh, right, we need to set the attribute first. Okay, so first what I'm going to do is I'm going to come down here and add a little bit of space in here. And I'm actually going to rename this to ends to 0. 0. I don't know. Oh, the number would have worked in there fine. So I'm actually going to just work on this stream here. So we're going to go to a primitive wrangle. And I'm just going to pull this guy over and then stick that in there. And what I'm going to do with this is I'm just going to call this, we'll call this maybe like break frame. We'll say set break frame. Cool. All right. So what I'm going to do is, oh, wait, no, sorry. My brain's not working. So let's do this as an integer because you can get some nice stuff in here pretty easily. So attribute adjust integer, we'll just say set break frame. So let's call this break frame. And this is going to be a primitive. So here's all of our primitive attributes. The operation is going to be set initial. We're going to say, random. And you could do this a couple different ways. Like you could do the middle and range. So like say you wanted it to go around, I don't know, frame 144 or something like that and have a range length of 9. That will give you, let's see, where's our break frame? Oh, it should be at the front, break frame. So this is giving us all stuff that's centered around 144. We could give it a 24 range length and that should be plus or minus 24. So there's different ways you could do this. You could do this with, you could do the minimum maximum. So we could say we want it to go from, I don't know, 144 to 216, something like that. I don't know. But I kind of like the middle and range length. That kind of sounds fun. So we could give that a shot. It's going to be around 144 and it'll go second either way. So it'll be basically 120 to 168. And we want to just work this on our, what's the group name again? Right attach, or no, left attach. That's right. So we'll say left attach. And you can see that these have all now gone to 0. And if we find the left attach group right there. Those have attributes. So we can also in here, in this attribute adjust integer, we can set the default value. So I'll just set it to -1 just to make sure that it doesn't accidentally trigger it at all. I mean, 0 is not going to trigger it either, but we'll do -1 just to be safe. Okay, so we've got those attributes now. So now we're good. Now we have our break frame. We know that that's what we want to look for. So we're going to go back in here. We've got our geometry wrangle, right? And so let's say if at break frame is equal to at frame. And I just learned something. I think you can do this and it'll read that as an integer now. Yep. Oh, I'm getting an error, but let's just see if that works. If I do this, let's just see. Yeah. Okay. So I'm pretty sure that this is a way of telling it to read the frame as an integer. I saw this in John Lynch's Vellum thing that he did from SIGGRAPH, which is amazing if you haven't seen that yet. But anyways, I'm pretty sure this casts it to an integer. I just never knew that in Vex. I don't know how I missed that. But okay, so break frame equals the frame integer. So those are both integer values. So that's good. So, and the reason I'm using like integer frames and everything like that and integer numbers is because then you're not dealing with like, fractional floats and stuff like that. That way, on that frame, you're going to hit a specific number. It's not going to be like trying to hit like frame 2.17. Like obviously you're never going to fractionally hit that. So anyways, so let's say, let's try this. I at remove equals 1 because it's one of those pseudo properties, I guess. So let's give it a shot. If we can set remove to 1, that's going to break it apparently. So let's see. Oh, you know what? I'm just going to set this earlier, actually, just to get a little quicker with it. So let's just break this around 48, and it'll break before it moves. And we'll see what happens. Nah, just kidding. It's not going to break. Gotta be kidding me. Why would it break? Nailed it. Let me just make sure everything is set the way I want it to. Break frame. Oh, it's running over points. How about we run it over primitives instead? Get some actual things happening here. All right, I think I can just run it while I'm watching here. Dang it. Let me just try this without, just to make sure it's not that. Could be that. Okay, I'm definitely missing one thing here, I'm sure. Oh. Oh, yeah. See, this is where you get into the here lie monsters. Top data myself, maybe. I don't know. Let me just see. Let me see if I'm just missing something simple here. Nope, that didn't work. All right. This is hopefully, I don't know. We're trying. We're going to make it work. Darn Let me just make sure that this is actually, these actually have attribute, those points set. Yep. Okay, there they are. Okay, well, we know they exist. Oh, you know what? I can just do something like this just to make sure that we are, just to see if we're getting anything here, because maybe remove equals 1 is not the right thing to do. Well, I mean, hey. Look at that. Although, why is it not setting back? Oh, because it's... Oh, yeah. Right. So this is this is a weird thing, too. We're in DOPS world, right? So we have... It's a simulation, and it's going frame by frame. So each frame, it's rerunning this, but it's not, like, setting it back. So what I could do is probably say... So it's definitely this. So it's working, obviously. Let me just see if this works too. I'm not sure if this will work. Let's give it a shot. Yeah, that's working fine. All right. So maybe I was right at the beginning and it was just the remove. Should have done this earlier. Sorry. Yep. Okay. That's working too. Weird. Okay. So I think the other thing that could be is group broken. I think could work. So let's try that. Or I'm also gonna just, I'm getting close to jumping into the into the help documentation. Ah, gosh, that's so annoying. That is so freaking annoying. Huh. The other thing I could possibly do. Oh. Sorry. I could just do the remove primitive. I can just do remove prim. So it's going to be the geo handle, prim number, and points. So 3 ints. So I'm just going to do 0 at prim num and then 1 because I want the points as well. That might work. Good. Could work. Yes. There we go. Come on. First try. That time was actually a joking first try. Okay. So let's reset this to something that's going to make a little more sense, like 144. Cool. All right. So now we can let this twist up. Yeah. Right now, there's no remove attribute in your spreadsheet, but that's to be expected because it's a pseudo attribute. Yeah, I'm not sure what that pseudo attribute thing is. Like, I really thought that if you set it to remove to 1, that it would be fine and that would work. But why it's not, I don't know. That's an interesting question. I'm not 100% sure on that one. So what I'm doing now is instead of trying to do any weird like attribute thing where it's going to delete it automatically for me, I'm literally just removing them. So now I'm removing the primitives. 0 is just saying this current yeah, okay, I see what you're saying. There's no list of remove equals zeros. Yes, because if I did like at remove equals 0, That should show up in here, I believe. Maybe not. Oh, interesting. What is, maybe we've figured something out here. Oh, just a syntax error, the semicolon. Yeah, so there's that. So I don't know. Yeah, I'm not sure what's going on here because, like, I think here we still have, we should still have remove in here. We do. And if we did I at remove, it would be like that. And so, yeah, why this isn't, I mean, it's obviously showing that there. Let me just reset this back to where it was so we can check that. But like, yeah, it wasn't, yeah, I'll just say remove just so we can see it here, and break frame like that. Cool. Yeah, those are all, they all set to 1, but clearly that's not what we're looking for here. Yeah, I'm not sure. Let me just hit up the help here real quick. Remove. Yeah, I'm not sure. I really would think that would be how that would work. But obviously there's something more at the root of what's going on here. I think we could actually, I'm wondering if there's any things in here with like attributes. No, that's a different thing. Okay, well, oh, maybe here, Vellum attributes. Yeah. Okay. Let's see. So that's on a point. There's so much stuff in these documentations. It's crazy. Breaking, break threshold, break type, sliding, stress, targeting. No, nothing about removing here. So these are all of the different attributes that you can set on things in Vellum. So a couple things. It's kind of crazy. Anyways, all right. It's working the other way. I just commented it out here. So this is working. Why this isn't working or why none of those work, it's beyond me. But here we are. Okay, cool. So that is working. The only other thing I'm kind of thinking of here is maybe having a little more mass would be interesting. It just seems like they're so floaty. I just want to see if that helps. Yeah, that might be helping. All right, let's try that. Let's set these middle value back to 144. Let's really give it a good long time here. Yeah, there we go. That's a little more interesting. We weren't getting any like swing with the wires and stuff. It was just like so bleh. Like it wasn't like nothing was happening with them. There we go. All right. All right. I wonder if I up the... Oh, you know, let's just go crazy. Let's just go crazy. Just wonder if I get... Oh, God. Look at that mass. That's too much. I made them so saggy now. They're too heavy. Way too heavy. All right. I just was just playing around here a little. All right. Let's set that back to, I don't know. We could try 0.2. See how that looks. Oh, is there a drag in here also? There might be. Oh, yeah, that's it too. There's a wind drag. Might want to turn that down a little bit maybe. Oh, that was weird. So the next thing I'm going to play around with is like some orientation stuff on these. See if that... Oh. You know what? I'm actually kind of interested in that. Just going to do something real quick. I just want to see if that mass that I added there, if that took away from that. Delete channels, and I don't want this one. Delete channels. I just want to see if it is more stable now. Like maybe the mass helped a little bit with that, just out of curiosity. Just gonna let it go here without moving upwards. I just want to see how it comes to rest here. If it's crazy jittery or if it's a little better. Might be a little better. Oh, those are all releasing. Dummy. Sorry. Yeah, so hopefully this is all making sense so far. You know, there's obviously a lot of variables in all these things. So, you know, doing any simulation is going to take, you know, time to calculate and do all that kind of stuff. So the next thing I want to try to do here is get some orientation on these so that they so that if I added some geometry to it, they would it would be able to, you know, you'd see the twist and things like that. I actually think this is going to be a little bit more stable. Maybe. Kind of tough to be specifically quantitative about that, but all right. Anyways, like that. We'll just go back so it's not so heavy. All right, and then I can just switch this back over. Cool. All right, I'm trying to think if I think what I'll want to do is put the orientation on first before we do the simulation, actually. So what is the... Oh, there it is, orientation hunker. My brain wasn't seeing it. Okay, so we've got that. And let me just see if I can do the... I think... I thought that would show the orientation on it, but that's okay. Let's just see. We'll just do up and N. All right, I will do... Just going to color these so I can watch them a little bit easier. We'll do N as blue, and we'll do up as green. All right, let's just sim this through and just kind of watch that, and hopefully we'll get... Well, that's weird. Well, whatever. I can watch those. Make enough sense. Think they should stay in their orientations pretty well. Just want to see if they're actually going to twist around. Maybe. They don't look like they're twisting, though, which is interesting. Let me just try one thing here real quick. Let's just change this to a hair constraint instead. Don't know if that's going to make any difference, but we'll give it a shot. Did that change? Sorry. Did that change the stiffness? It seemed like it got stiffer there. Okay. Well, it didn't. All right, let's just see if... Hey there. Let's just see if that does anything interesting, if that gives us any better orientation kind of stuff here as they're like moving against each other. I guess they probably wouldn't be twisting, I guess. Kind of hard to say. All right, well, let's try it after. See if that does better. I don't know. Maybe I'm overthinking this. Nope, that doesn't seem right. Some weird... maybe. Maybe it is okay. Kind of fun looking. Yeah, let's try it. Let's see what that looks like if we put some sweeps along that or something. All right. I think I'm going to set this back to the string constraint. All right, cool. Let's see here. Let's do that. Okay. Cool, we're simming. Oh, that's right. I want to have those disconnect too. Turn this back on. All right. Let that go to the end. Yeah, so hopefully everything here is making some sense. Let me know if you guys have any questions or thoughts or anything like that. Obviously, always love to hear from you guys. And gals. Sorry, I always say guys. Okay. Cool. Cool. All right, so let's do like a sweep. Oh, let's do a square tube. Yep, there's those endpoints that we were talking about. So let's fix those. So let's do an attribute promote. I'm just going to do p scale from the point to the primitive and back again. Although I don't want to do it as an average, I want to do it as a maximum. And then there we go. Now that should be right. Yep. Now, instead of a square tube, I think it would be kind of interesting to do something different here. So let's do a grid. If I can type. Okay, cool. And let's just do a 2x2, and we'll do it in the X, Y, no. There we go. And I'm going to do a reverse because we want this to be flipped. So that's good. And let's change the size of these. So I want one side of it to be really thin, so maybe it's like 0.5 or something like that. Maybe we'll make these like some sort of little straps or something. I don't know. Let's see how that goes. Okay. That's interesting. Yeah, the orientation along the curve is definitely not... Yeah, so it's it's like right here it goes boom, like that, right? So that's not right, first of all. Now they're all flat, which is silly. We don't want that. Well, I'd rather it calculate that properly than freak out at first. Because at first it's got a little bit more interest here, and then it kind of all jumps. Doing some interesting stuff, but the other thing that we probably need to do is make sure that these aren't super penetrating, which they are a little bit. So let's just adjust this. This might need to be at 1. No, we can probably have this at like 1.5, maybe 2. Maybe 2 will be fine. Yep, actually that would make sense to be at 2 because that should fit inside of the radius. Because if you... Looks like linguine. Yeah, there you go. Linguine. Pasta. All right, let's take this off here again. Let's bring it back up to the top here. See what this will do. See, yeah, that's more stable that way. I like that better. I'm not sure what it's going to do at this point, but let's see. Let's see what we get. Yep. That was what I was afraid of. Looks fine when it's in the one state, but it's not respecting those orientations. It's like it's not rotating those, which is kind of odd. So it's keeping... So that's great. I like that it doesn't like recalculate that. But once we start to change that orientation there, they flatten out. And what's going on there is that these, if I turn these back on, the vectors here, I don't need to have that one, I guess. I can just turn that one on, right? Maybe. No? That's weird. That's really strange. I don't know why that's not showing up. Normal? Do I have normals here? Okay. Apparently not. Really strange. So we have this orient attribute, but it looks like those are not getting recalculated at all. In fact, they definitely are not. So let's try turning that off, because I know that that should supersede the other two. So let's see. We have a normal there. We have the up. Oh, yep, I'm not on the node. Nope. Interesting. Let me think about that. Changing orientation. Why is it not picking up those attributes? Maybe it can't. That's really interesting. Just thinking if I can set those point attributes and then transform them, like as they're transforming, we could start the calculation from there. But I don't know if those are actually getting adjusted here. Let me just look. So many little things today. Hopefully you're learning something. That's the goal. Hopefully I'm learning something too. Good Lord. All right, turn that off. Okay, so I want to see... Oh, right, because those aren't actually getting transformed. Excuse me. Oh. Is it these? Is it this that's going to help me with that? just going to look at something here. No, it's not that. Yeah, see, this is what I'm thinking of here, the orientation pin type. If you have pin to target set, but this is not, this is what I'm thinking of here, and why is that not in the other one? Because it's not. All right, let's try this. Just for kicks. Let me try this. Okay, not going to do that. So this should move all of the constraints. Okay, what if instead we do these? Just out of curiosity. Let's see. Will that adjust those attributes? Where are they? Up. Interesting. It doesn't even have a normal anymore. No. Oh, well, I guess something could be. Let me check. The start group is the one I was tweaking. Yeah, so this is a little bit different way of doing it with the pin to animation method. The problem here, I feel like, is that if we look at the constraint geometry, I don't know if you actually get another. No, you don't. You only get wires. So that's kind of the tricky part there, is that you don't actually get another. Really there, Houdini. Huh. Look at that. We got a little fault. Don't need that on my desktop. Thankfully. Think we'll be okay here. Wires, yes. Cool. Okay. Well, let's get rid of that. Turn off the pin to animation. Let me just see if there's anything else here. Stitch points, weld points, stitch points. Is that a thing? I think it's a thing. Let's see. Unlike another. Yeah, I'm not, honestly, that's the funny thing. I've never used any software that rhymes with Krya. I'm more of a Shmi 4T user. So that was, and man, talk about random crashes. Oof, that was brutal. Cause it was just brutal. Anyways, I'm just curious if this is gonna do the same thing. It might not, but no. I'm just wondering if I'm using the wrong attachments, maybe, that other things would do better. Yeah, this would just want to glue it. don't think that's going to work at all. Yep. Yeah, I'm just really surprised by that. Oh, that's not what I want. Attach the geometry is fine. Should work. Yep. Okay, well, anyways, that's all well and good. Let's just do one more thing here that I think is pretty neat. And that is the shape matching stuff. So let's just try to drop some geometry on here, maybe, just on these things as it's twisting and stuff like that. So, I think I've played with this before, but I don't know. Let me just grab like a pig head and actually we'll just do a flip. We'll just do one. We won't do anything too crazy here. Oh, cool. Yeah, let me just do that real quick. Let's just do nope, it's not a flip. It's a toy. Oh, that's right. Oh. I got it. All right. I'm going to take a quick coffee break because I've got something cool to show you. It's not going to be really a coffee break, but at least it's just a break. So I'll be right back because I've got something really fun to show you guys that I got from SIGGRAPH. So I'll be right back. All right, I'm back. No coffee. Okay, so SIGGRAPH got some swag, so I figured I should probably show it to you guys because it's pretty fun. And if you come to a Houdini event, maybe in the not too distant future, you could get some stuff. Well, first of all, I got this, which was really neat. I don't know if you can see that, but they didn't have the teapots from the Pixar thing, but they did give out pins, little limited edition teapot pins, which was kind of fun. So that was exciting. And then on the Houdini side of things, got some swag. So if you come to a Houdini event, which there will be some over the next kind of fall season here, we have some test geometry here, little squishy test geometry. And there's another one I that I think is in the works to come. So yeah, Flippy. I know. My wife literally was she's I think at the 19.5 release they had some of these, and my wife saw that they were on their their chairs at the event, and she was like, "Oh my gosh, you got to get one of those." And I was like, "Oh, okay, I'll see what I can do." And when I saw that they were at SIGGRAPH, I was like, if I don't come home with one of these, I think my wife is going to kill me. Because, yeah, Flippy, he's so cute. Look at him. He's so great. And they're squishy, but you got to be careful with Flip if you get one because the back of his neck will break. So a few people have snapped his neck off. So anyways, those are my little, when I typed in Flip, I was like, oh, that's right. I got to show everybody my Flip. So anyways, okay, so let's grab a rubber toy here. That should be fine size wise. Yeah, that should be great. All right, so we're gonna do a vellum match. Nope. Vellum. What is it? Vellum shape match. Configure grain pieces. That's what it is. So here's what we're gonna do. We are going to take these two things here and make some stuff out of them. All right. So I actually used this I did like a little internal thing, like a little splash screen contest thing or whatever. But so the way that this works is that the first part here is going to, we're going to use sphere packing, and it's going to pack all these spheres into this geometry. And then from there, the shape match will basically make sure that these are rigid and they're all together. So what I'm going to, let's see here. There we go. Looking a little better. Just want to make sure that these are actually fitting in here. Well, let's see. Can we do a few more maybe? You know what? The pig head's going to be easier to do. I'm just going to be tweaking this too much. Let's do the pig head instead. Call it good. All right, pig head. There it is. Let's see. Scale. Sorry, I don't know why this is acting so weird. I did this before and it was fine. Huh. Weird. Yeah, you don't really want to go too high with the maximum spheres. That's part of the issue, is you want it to be as few spheres as you can. I just don't know why it's not matching it so closely. I had it working with another thing before. I might. Yeah, you're right. I mean, obviously you could go more than 200, and it, like, if they were smaller, you might be able to do like something crazy and really push it. But like, the idea is to have, yeah, like that's just getting ridiculous. Like, you don't want to do that. You want them to be as few as possible, but have it kind of go throughout the whole thing. So, all right, I'm just going to sort of, maybe flip would be easier. I don't know. Nope. I keep typing flip because he's flip. All right. Let's try this again. Maybe I was smarter to go this way. Okay. Let me just reset this. Oh, no, that's not what I want to do. Sphere packing. We'll set this back. Yeah, that'll be fine. That'll be fine. I'm sure that'll work just fine. All right, great. So, okay, so we've got this. So what we're going to do is we're going to emit these in, and what this is actually doing as well is it's naming them. Or I'm sorry, I need to have a name for it here. So, yep. So what I'm going to do is add a name here. We'll just call this toy. And that should help us out, I believe. Oh, there we go. Yep, piece attribute. So instead of that, I'm going to define the pieces from name, I believe. Oh. Yep, that's a problem. Let's just do this. Just do a Boolean union of these. Just have them all be connected. Toy. Shape match. Should all be one piece. Yep. Okay, cool. All right, so that's looking good. And what we should do from there. So what I did there was just with this Boolean, it's just basically making sure that everything is all connected together. These pieces that are going inside here are now just like one unit. They're not all like separate. So that'll just make sure it's all one thing. Okay, so now if we do this, let's see, we'll do a null here and call this geo, and then this one constraints. So there's my points that it's going to shape match to. And what I can do is source this in to here. My SOP path is going to be geo target constraint path is going to be cool. Great. And then that I'm actually going to raise up to. So let's do that. Transform. So I know I'm actually dropping it on there. And let's just do one to begin with, maybe. Ground position here. Make sure this is all working right. I'm not sure why that's not colliding with those. It's colliding just fine by itself. Huh. That's really odd. So the way that you do that, and then let me just show this, I guess. Split this. We can split this out here. We'll just do the wires. Oh, maybe that's the problem. Sorry. Make sure this is not like the same object, because that could be a problem if it thinks it's the same, all the same object. You know what I mean? Like if it's all the same geometry, it could get a little confused. Shape match. Yep. So this is all one. So what it's doing here is it's actually making these all as one geometry in the shape match. Okay, so I could So this is, yep. So I can have both of these here. So this is probably the default. Yep, there we go. So that's that. And then we can do Vellum, transform pieces. Let's just pull this in here maybe. I literally just did this with all these sprinkles and I'm like blanking on it completely. I did this whole simulation with a ton of sprinkles. All right, well, let me just show you that, I guess, instead, because that's actually working and I can just walk you through it real quick. So why don't we do that? Instead of trying to sit here forever and be all crazy. So I made this still life thing for like a little internal contest at work, and basically just supposed to be summer. So I decided to do ice cream with a ton of sprinkles all over the place. So I'll give it a second here to do some of its simulation, or not simulation, just some of the caching that it needs to do. Hopefully it won't take too long. So what I was using this for was a bunch of sprinkles, because I realized that I could do a ton of them quickly, and I wanted to use this shape match thing since I was trying to use something new from 19.5. So instead of doing rigids and, like rigid body stuff that obviously could handle this as well, I just decided to do it with Vellum just to make it a little more interesting. And since I knew they were just little sprinkles, I could just put a few points in them and it should keep its shape pretty well. Oh man, there's more caching in this than I thought there'd be. Should have saved my my geometry. Should have saved a cache. Go, you can do it. You can do it, Houdini. My apologies for the thrilling content. As you can see, I rendered in Karma and brought everything into Solaris. Here's my setup for it. See, I'm not sure why that name attribute wasn't going through properly, unless I was doing it the wrong way. I mean, obviously I was doing it the wrong way. I just must have been doing it in the wrong order. This is what you get when you do things way too quick and dirty. All right, let me. Yep, this is my two screens, and these are all wacky. All right, let me just bring this back to my single screen look. Okay, here we go. We got an ice cream cone here with sprinkles on it. Looking great. Okay. So here is the sim that I ran. Okay. There we are. Just going to hide the other objects here. So we have all of these little sprinkles that I was dropping into the scene. And as you can see, they're all just points. They're all just these packed transforms. So what I was doing was I was using the sprinkles in, which each had a name attribute on them. Each of them were coming in as sprinkle. I had 3 variations, sprinkle 1, 2, and 3. So if we look here, we can see that there are 3 variations, and I can just show you that one of them, there's sprinkle 1, or sorry, I'll delete the non-selected there, sprinkle 1, sprinkle 2, they're all just different sizes, same thing. Okay, so brought them in here. I did the same sphere packing thing I was just doing there. There it is. Basically fits to the sprinkle. This then makes the shape match. This was using the name, which, yeah, I don't know why it was having a problem with it before, but okay, there we go, shape match. Packed it into just one point, copied the name attribute over to it, I think. Right? Why is this? Oh, it's just yelling at me. It did copy the name attribute over, which is in the detail. Promoting that over. And then there are my 3 sprinkles. Each of them has a name on it. They're all packed into one primitive. The reason I was doing that was because I was copying them to points, which is a little different than how I was going to do it in the other one. But hey, here it is. So we're copying them to points. Why is that taking so long? Oh, because it has to run the stuff that's up here, because there was some other things happening there. I basically painted that. Oh, interesting. Didn't save that. So anyways, so these are all the points where they're coming at from up here. And then I am basically just giving them a new, like I'm renaming them each frame. The reason being that you want to have these points all have their own name each frame, and then unpack them and make sure that you transfer the attribute down. So now we've got all these sprinkles that are named. In fact, if I turn on, it's probably hard to see, but if I turn on this name attribute, oh, you can't see it there, but here you can. You can see now they all have their own unique name that it's reading out on the points. And they're all being emitted in like this, frame by frame. And so from there, so at this point we have, this is on the constraint geometry points, and on the Vellum geometry itself has a name as well. So these should all match together. Whoops. And then, so basically you want to have a name on each of those, on both the Vellum geometry and on the, on the constraint geometry as well, on the points. So you need to make sure that those all match. So the point on the constraint geometry, the points on the Vellum geometry, I'll get a name. Then that makes sure that they are all unique. And really, I just put that into the solver here and let it do its thing. And this should be saved. I don't think I saved it all the way, but these are all, so there's a ton of them coming in here. You can see that this gets up to, good gracious, it gets to a few million points. And I think I stopped it at, like, for my render was like, I was like, oh, I'll have it stop like right around here at like frame 62, so that there'd be some that were like falling down here. And so that's the, you know, we've got 2.7 million points in here, and they're all individual sprinkles and all that kind of stuff. The one thing that you can actually turn off if you just have these rigids in here, oh God, that's going to try to simulate. I mean, not that it would take that long, but I don't want to do that. So the one thing you can turn off is self-collisions in there. You don't have to have self-collisions on, which is obviously helpful for the calculation and stuff like that. But then in here, let's see, I just changed, that's right. I just took the beginning part of the name because the sprinkles at this point had these extra things on here just to make sure that they were unique. One of the things I was setting here was when these unpack, enforce unique name attributes per instance, because each of the copied, you know, points all these points were all packed together. So as we unpack them, especially in this Vellum unpack, you want to make sure that each has its own unique name. And therefore, that's where these extra names come in here, which I believe is this end part, 2626 in this case, because this one adds in the frame number, which is just here like 62. So I'd added in the frame numbers to the end of the name attribute. So anyways, so what I'm doing is basically just stripping the end of that off. So it's just the name now. Now there's only 3 names in here. You can see they're all now colored to 1 of 3. Same thing over here with the constraint geometry. And then this is the piece this is the node that does all the fun action. I wasn't sure exactly how I was going to do this because I was thinking, okay, maybe I'll just have it transform by geometry to all these points, but you can do it 2 different ways. You can have it do transform geometry, which in this case I would need to put in the geometry here, which I think I could do. Let me just see how this will work. No, that is not working. Why is that not working? Do we not have a name attribute here? No, I do. Well, anyways, what I had done here was points with transforms. So I've got all these points that I could instance this geometry onto, or I could do whatever with. Then I could randomize the color from here. If I turn this off, you'll see now they all have random color. I time shifted it just so that it would only sit right at 62, so I didn't have to, like, if I moved my timeline, it would just stay. And then down here is a copy to points, which copies all of those geometries onto, and I actually have it as a packing state here. So it's actually, it'll in the viewport, it'll unpack, it'll like unload the ones in the background here, so you can still see them, but they're just kind of in the background. So there's all my sprinkles. So that is more or less how you would do that. Now, why that wasn't interacting with that sim, I'm not 100% sure. I have to debug that a little bit more, but it's kind of a really nice way to do it. And this is all thanks to John Lynch's Vellum SIGGRAPH presentation that he did with the Houdini Hive. And it's in the Discord if you're on the Discord channel. So I posted that in there. It's a really great watch. It's like an hour, but there's a lot of really, really good stuff in it. He talks about fluids. He talks about rigid bodies, all that kind of stuff. So he's obviously way more in depth on this stuff than I am. But so that was kind of how I had set this up, because I wanted to be able to copy a ton of them at once in one big grid and have them all dropping frame by frame without having any, issues or any, collisions of names or things like that. So it all worked. So I don't know why that other one wasn't working so well. But yeah, it didn't really like it. I guess, you can see here too that this is way more stable, even just at I only had 2 sub steps in there. You didn't really have to go very far with that. And I could turn off self collisions as well. That was a helpful thing too. So yeah, I don't know if anybody has any questions or any thoughts or anything like that on all of this. I know I went through that kind of quick, but I just wanted to show you how it actually worked, so that you could see it working and not me failing completely. I might try to, I don't know, maybe I'll look into that a little bit more as to why that wasn't working. I was really hoping that those would work together, but fortunately it didn't. But it is now 10:30 over here on the East Coast of the old US of A. And I'm going to be calling it an evening here. So yeah, hopefully you guys got a little bit of, something interesting out of this. As always, if you guys are looking for anything, yeah, of course, Zach, I'm glad you guys all stuck around and hung out. Yeah, please always put in ideas, thoughts, whatever for future streams in the Discord. I know there's some in there, but I was trying to like dig through some of them and see what made sense to work on. So if you guys see anything, or you're like, hey, this is kind of neat, I'd love to see how to do this or whatever. One thing I was kind of thinking I might do next time is kind of an oldie but a goodie, doing like a flip waterfall, and adding in some nice velocity fields, kind of pushing up against it as it comes down to kind of turn it into a little bit more of a misty thing as it comes down. Thinking of maybe doing something like that. Actually, it was a presentation that I saw from a bunch of years ago from my now current boss, which is kind of funny, but he had done a presentation at a Houdini user group. So I'm thinking maybe I might do that. But if you guys have things that you really are interested in, I'm also going to start connecting with my coworker Michael, who is awesome at rigging and KineFX. So I think he's going to come on the stream. It's coming up soon now that I'm kind of back in my mindset from SIGGRAPH. I think I'm going to, hook that up with me and him, and maybe that'll be sometime in September. I do have a little travel I'm doing in September as well, but kind of hoping we could do maybe sometime in September. So keep an eye out for that. I'll mention that in the Discord when that's going to be. And so if you guys ever have any questions or thoughts, or you see an old stream and you're like, hey, what is this? Or why did you do this? Or you totally messed this up, which I've messed plenty of things up. So, you can always drop it in there as well. So great. Well, thank you guys so much for joining me. As always, you can check us out at HoudiniHangout.com. I think I'm also in the next coming weeks going to put up a calendar on there, I think, of some sort, just to kind of show when I'm going to be streaming, like my upcoming dates, just as a way to be able to find that if I'm having to change things or whatever. But so links to the stream, links to Discord are on the site. And I'll see you guys next time. Thank you guys so much for joining. See ya.